Hello, my name is Josh Reingold, and this is my Physics 2212 Lab 4 Faraday's Law. The purpose of this lab is to collect data of a bar magnet falling through a tube of aluminum foil, simulate the same experiment using GlowScript, and then compare those results. The primary physics principles used in this lab was Faraday's Law, shown above, and the flux equation shown below. The main results of this lab was that the experimental fall time of the magnet was about 0.56 seconds, and the simulated fall was about 0.41 seconds. Some justifications and assumptions made in this lab are that Faraday's law shows nature's resistance to change in flux, and therefore explains why the magnet falls more slowly and allows us to use the previous equations, and that the battery falls straight. The aluminum foil is treated as a set of loops, and air resistance and other external effects are negligible. To initialize this experiment, the system was defined as the magnet and the foil. The surroundings were everything else, and the initial conditions are that the magnet is dropped from above the top of the roll of aluminum foil. The methodology for this experiment is defined below. Firstly, the north pole of the magnet is labeled. Second, the tube is held vertically. Third, the magnet is dropped through the tube. Fourth, the time it takes to fall is measured and recorded. And finally, the previous steps are repeated 5 times, and the average of the fall time is taken to ensure clear and sound results. This is some of the GlowScript code used in this experiment. To help explain some of the code, the following questions are answered. If the magnet is flipped, the resultant motion is the same, but the induced current switches directions. The experimental magnet falls more slowly than the simulated one, and this is most likely due to external factors that the simulation doesn't account for, such as air resistance, imperfect magnetic fields, and the orientation of the magnet. Finally, it shows that the velocity asymptotes to a constant, meaning that there is zero acceleration and therefore zero net force. The data of this experiment is shown here. The first trial took 0.53 seconds for the magnet to fall. The second trial took 0.6 seconds. The third trial took 0.62 seconds. The fourth trial took 0.56 seconds. And the fifth trial took 0.49 seconds. This created an average time of approximately 0.56 seconds. Some other important data in this experiment are that the length of the tube is 30 centimeters, the radius is 1.5 centimeters, and the mass of the magnet is 0.029 kilograms. Some potential error in this experiment is the possibility of friction between the magnet and the tube, some human error in measurements, and the potential for air resistance. What if the conductor resistivity was reduced close to zero? Due to Ohm's law, near zero resistivity would cause a very large induced current, therefore creating a large magnetic field and causing the magnet to fall at a slower rate. What if there were holes or slots cut into the tube? Holes and slots would interfere with the magnetic field created by the aluminum foil, thereby decreasing the magnetic force and causing the magnet to fall at an increased rate.